Imagine everything you know squeezed into a space smaller than an atom. That's how our universe began. About 13.8 billion years ago, a massive explosion, the Big Bang, set the universe in motion. The Big Bang wasn't an explosion in space, but rather an expansion of space itself. It's hard to wrap our minds around, but from that tiny point, everything expanded outward. The universe has been growing and changing ever since. The universe is everything around us. It's all the stars, planets, galaxies, and everything in between. It's also the vast, empty spaces and the energy that fills them. The universe is incredibly vast, stretching out billions of light years in every direction. A light year is the distance light travels in a year, which is a mind-boggling 5.88 trillion miles. The universe is so big that it's hard to imagine its true size. The early universe was incredibly hot and dense. As it expanded, it cooled down. Over millions of years, this cooling allowed the first atoms to form. These were mostly hydrogen and helium, the simplest elements in the universe. These atoms would become the building blocks for everything else. As the universe continued to expand and cool, gravity started to play a crucial role. Gravity pulled matter together, forming the seeds for the structures we see today: galaxies, stars, and planets. This process of cosmic evolution is a testament to the power of simple forces acting over vast stretches of time and space. Billions of years ago, gravity began to sculpt the early universe. Huge clouds of hydrogen and helium gas started to clump together under their own gravitational pull. These clumps became denser and denser, eventually collapsing in on themselves. As they collapsed, they spun faster and faster, just like a spinning ice skater pulling their arms in. This spinning motion flattened the clumps into disks. These spinning disks of gas and dust became the birthplaces of galaxies. Our own Milky Way galaxy, a vast spiral of stars, gas, and dust, formed in this way. The Milky Way is just one of billions of galaxies scattered throughout the universe. Each galaxy is a massive collection of stars, gas, dust, and planets, all held together by gravity. Within these galaxies, smaller clumps of gas and dust continued to collapse. These smaller clumps became the stars that light up the night sky. Stars are giant balls of hot gas, mostly hydrogen and helium, that produce their own light and heat through nuclear fusion. Fusion is a process where atoms combine to form heavier elements, releasing tremendous amounts of energy. As stars formed and died, they enriched the surrounding gas clouds with heavier elements. These heavier elements would eventually become the building blocks for planets like our own. The formation of galaxies, stars, and planets is a continuous process that continues to shape the universe today. Stars are the cosmic engines that drive the evolution of the universe. They produce light and heat, forge heavier elements from lighter ones, and influence the formation of planets and galaxies. Understanding the life cycle of a star is key to understanding the universe as a whole. Stars form in giant clouds of gas and dust called nebulae. These nebulae are cold and dark, but gravity can cause regions within them to collapse, pulling in more and more gas and dust. As the material collapses, it heats up, forming a protostar. If the protostar gathers enough mass, the temperature and pressure at its core become so intense that nuclear fusion begins. Once nuclear fusion ignites, a star is born. The star enters a long, stable period where it fuses hydrogen into helium in its core, releasing a tremendous amount of energy in the process. This energy creates outward pressure that balances the inward pull of gravity, keeping the star in equilibrium. This stable period can last for billions or even trillions of years, depending on the star's mass. Massive stars live shorter, more dramatic lives than their smaller counterparts. They burn through their fuel much faster, leading to a more violent and spectacular end. When a massive star runs out of fuel, it can collapse in on itself, triggering a supernova explosion. Supernova are among the most energetic events in the universe, briefly outshining entire galaxies. The death of a star, whether through a quiet fade or a dramatic explosion, is not the end of the story. The material ejected from dying stars enriches the surrounding interstellar medium, providing the building blocks for new generations of stars and planets. In this way, the cycle of stellar birth, life, and death continues, driving the evolution of the universe.